Welcome to this presentation on computer engineering-based solutions for road safety in India. We, Yagnik, Mazad Zavari and Mehul Raval are part of the Intelligent Transportation Research Cluster at Ahmedabad University. Let us look at the road accident scenario in Ahmedabad, Gujarat. The major factors for accidents are improper driving, speeding, incorrect judgment by driver, lack of proper road marking and signage, lack of proper pedestrian infrastructure, and deficiencies in road infrastructure. 58% accidents within human factor are due to improper driving, improper lane change or usage, illegal road usage, including traveling in the wrong direction. 42% of total accidents are related to improper road infrastructure. Let us look at drone-based data collection in the Ahmedabad region. Let us look at the semi-automatic and very time-consuming task of data annotations. Using the GUI tool, we can adjust the location, height and width of the bounding box around the object. We then apply the changes to several frames of the video. We now provide a class or category label to the whole track of the object. In this example, the class is sedan. In this way we can create a large repository of various objects, also known as ground truth data for training machine learning algorithms. Let us look at object detection. Object detection results of YOLO5 algorithm, where some motorbikes, which are small objects, are not detected. We get better results when we use YOLO7 algorithm, which is based on higher resolution input images. Object detection using YOLO5 is rotation invariant. However, there are some misclassifications, especially for small objects, because our initial results are based on training on another dataset, the Version3 dataset. Object detection using YOLO5 is scale invariant. However, there are misclassifications. The results will improve when we train the YOLO algorithm on our own drone dataset consisting of pure aerial images. Let us look at object tracking. The blue line shows the track of the car in the red bounding box. The blue line is the centroid of the red bounding box as the car moves. Tracking techniques are based on IOU method augmented with Kalman filters or feature-based search methods. Let us look at examples of traffic violations. Shows an example where a car incorrectly uses the lane or area within the T intersection to overtake. This is a punishable offense under motor vehicle driving regulations. Shows an example of pizza delivery motorbike violating several rules. Motorbike is driving on wrong side, violating traffic signals, driving on the pedestrian crossing. These are punishable offense under motor vehicle driving regulations. The car in the red bounding box avoids the use of the roundabout, and makes an incorrect short right turn, and hence, is driving against the clockwise flow of traffic around the roundabout. These are punishable offense under motor vehicle driving regulations. The motorbike takes a U-turn at the incorrect location, that is beyond the roundabout or junction, and hence, for some time it is hazardously moving against the flow of traffic. This is a punishable offense under motor vehicle driving regulations. Let us look at improper road infrastructure. In this example, we can identify the deficiency in road infrastructure and then infer that splitter islands should have been used to deflect the black car towards the left, so that the car goes around the roundabout, to take the right turn. The Design Guidelines IRC 65/2017 given by the Indian Road Congress, recommends the use of splitter islands for roundabouts, to discourage hazardous wrong-way movements. Track shown in blue color are hazardous movements. Thank you. Drive safely and stay alive.